Hello students, in today's lecture we are going to learn about digital electronics. This is the last chapter of basic electrical and electronics engineering subject. This subject or this chapter basically deals with the numbering system, Boolean algebra, truth table, logic gates, half adder and full adder. This chapter basically will not deal in depth with these all the concept. It gives overview of digital electronics. Before beginning with the concept, let me talk about what is digital electronics, why it is required, what are the applications of this digital electronics, what are the advantages of digital electronics. These things we'll see first. This particular screen, this image shows you examples of analog electronics and digital electronics. There are three examples are there. One is clock, another one is voltmeter, next one is joystick. The first column, these applications are belongs to analog one, as you know this, and these applications are belongs to digital electronics. Comparing with these analog system, these digital electronics systems are easy, simple and accurate one, hence we use digital electronics. The reason behind to show this image is to give some idea about digital electronics, and students should not get confused between analog electronics and digital electronics. I would like to show you some more images of digital electronics and analog electronics. As we know, digital electronics works on the signal which has only two states. One is high state and another one is low state. That high state is called logical 1 and low state is called logical 0. And analog circuit or electronics which deals with the continuous signal, and that signal values vary with respect to time. You can see with the help of these diagrams. This is the analog electronics signal. The signal is varying with respect to time. At every time its value is changing, and this type of signal will be used for the analog electronics. But in digital electronics, this type of signals will be used, and the signal will be only having two states. One, it is called logical 0, that is low state, or it is called off state, and it is called high state or logical 1 state, and also it is called on state. This type of signal will be there in the digital electronic system, and this is the example of again a analog system with particularly for a video signal. That is what it is written here, peak video reference. So that what the reason behind to show is that the signal having the various value with respect to time. Now next is this is the example of digital electronics, and here one more example is there, that is the example for analog electronics. Here operational amplifiers, resistors, capacitors will be used, and input there is a some voice is there, and at the output loudspeaker you are getting the large voice. That is basically it is a amplifier circuit, and this amplifier circuit is the analog circuit, and this particular diagram represents the digital electronic circuit, and which is using the flip-flops. It is a JK flip-flop, and here some ICs they have used, LCD display they have used, and some signal, clock signal they are giving. That signal represents the logical high as well as logical 0. This type of signal will be given in the digital electronics. Why I am showing this all the diagrams? To just give you some overview about digital electronics and analog electronics. What is digital electronics? This is the technology which stores, process or generates data in terms of two states. One is a logical 0 and another one is logical 1. Logical 0 is called low state and logical 1 is called high state. And this digital electronics transfer the data in terms of these states, these bits of the states, that in terms of 0, 1 it transfers the data. That transferring a single state or that transferring a one state of the digit is called bit, and group of the string, the group of the state string is called a byte. A single digit 0 or it may be 1, it is called a bit. And if a group of that 0, that means 4 zeros and 4 ones are together, it is called a byte. So this is how it transfers the data in digital electronics. Why digital electronics are useful? Because it is precise, it is compact, and it is easy to operate. It stores data easily. It transfers the data without any degradation. So hence these are the some advantages of digital electronics, as well as these are the cheap comparing with the analog system. Hence people will prefer digital electronics than the analog electronics. It doesn't mean that digital electronics doesn't have any disadvantages. It have disadvantages, but comparing with the advantages, the advantages are more and disadvantages are less. Hence people prefer digital electronics. Earlier in olden days, the computer were there, and those were made up of with the help of mechanical switch and relays, and because of that it was very slow and bulky in size, and it used to produce lot of heat. To avoid this, the modified computer were manufactured with the help of diodes and transistor. But these diodes and transistor were a problem because of its reliability and connectivity issues. Hence those were avoided, and it is overcome of those this problem. They have developed the computer with the help of ICs, integrated circuit. This is the reason to grow the digital electronics in the world. So this particular concept is required to understand why we are using digital electronics. And now this digital electronics, whenever we are using, it deals with some particular concept. In order to understand this digital electronics, we should know the numbering system, that is specifically binary number system, because digital electronics uses only zeros and ones. Hence we should know the binary number system. At the same time, we should know some Boolean algebra. Whatever algebra we use in mathematics for simplification and analyze, in a similar way, to simplify the logic expressions, we need to use Boolean algebra. So that we should know about Boolean algebra also. So hence let us try to understand what is this number system, Boolean algebra, logic gates and all, one by one. Now I will start with number system, types of number system. Basically there are 4 types of number system. One is decimal number system, second one is binary number system, third one is octal number system, and fourth one is hexadecimal system. This decimal number system, it is used by the human beings for all the calculations, and in this decimal number system total symbols were used for the numbering identification are 10, 0 to 9, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Total 10 symbols are used, and it is a positional based system. So that is what I have written here, 0 to 9, and base is the 10. That is the total number of digits what we have used is 10, hence the base is 10. Now how this 786 will be represented? So it is based on the positional system. This is the least, that means unity. This is the 10th position, this is at the 100th position. So 6 into the base is 10, so 10 raised to the power 0, 10 raised to power 0, 8 into 10 raised to power 1, and 7 into 10 raised to power 2. So 10 raised to 2 is 100, 100 into 7 is 700, 10 raised to 1 is 10, into 8 80, 10 raised to 0 is 1, 6 into 1 is 6, so if you add it is 786. This is how we use this number system, and we all people deal with this number system only, decimal number system. But if you talk about digital system or digital electronics, it deals with the binary number system. So hence this binary number system, it is used for the computers, and here only two symbols are used, those are the zeros and 1. As total symbols are 2, hence it is base is 2. So 0 and 1s are the symbols. Now to convert, because computer doesn't understand any these decimal numbers or any words, it will understand only zeros and 1. So in order to convert this any word, if you want to transfer, any picture, graphic, something, so those all the words, numbers, pictures should be transferred in terms of binary and then send in the binary system only. That is what binary number system only we have to represent, then only computer will understand. Otherwise it cannot understand these words, spellings, something, nothing. It will use only zeros and 1s. So we have to convert this into in terms of zeros and 1s. Next one is octal number system. This is here total 8 symbols were used, and base is 8 because total 8 symbols and base is 8. It is also positional system. So 0 to 7, so base is 8. Now here 735 I have written, base 8 I have written, so it is valid. That is what, if you write 975, then it is called not valid, because see here this 9 will not come in this particular number system, hence directly you can say it is not valid for the octal number system. That should be within these numbers only. And hexadecimal system, the 16 here 16 symbols are used, and base is 16 because 16 symbols we are using, so base will be 16, and it is used for memory address. And this octal number system also used for the memory address only. So here up to 0 to 9 numbers will be used, and after that 9, so there will be alphabetics will be used. Alphabetics will be used to represent the number. So A represents 10, B represents 11, C represents 12, D represents 13, E represents 14, F represents 15. So 0 to 15 is total 16. So 16 symbols are there. So hence base is 16 here. So and it will be used in the memory addresses, in microprocessors, in microcontrollers. It will be used hexadecimal systems. Hence what is required, there are totally 4 numbering systems are there, and we human beings deal with always decimal number system, and we know each other, we know about the decimal number system. So to operate with digital electronics, we should know the binary number system, and if you are operating with computer system, then this decimal number system should be converted into binary number system, or hexadecimal system or octal system should be converted into binary number system, because then only that computer can understand, otherwise it is not possible to operate. Hence knowing this numbering system is very much essential, and conversion is required. So then how to do this conversion? So let's see, conversion from one number system into other number system. This particular class I will take it in the next session. So this is what for today's class, what is digital electronics and types of numbering system. Thank you.